whenever we talk about rational expressions, which is what this unit is going to be about, rational expressions and equations, we have to consider non-permissible values. And those are numbers that could be put in place of the variable that would make the expression non-permissible, basically, but that make it a non-real number. So basically that happens when the denominator is 0. So if you have a fraction like 1 over 2, that's fine, but if you had something like 1 over 0, that's not a rational number. You can't have a 0 in the denominator of a fraction. So that's what we're going to be looking at first here, is numbers that would make a denominator equal to 0. So for example, if I had a rational expression like this, 2 over x, x could be pretty much anything, right? Except there's one thing that x cannot equal. Do you know what it is?
0.
0, right. 0 is the non-permissible value for this rational expression. So it means this expression is defined for every real number except for 0. Because if I put a 0 in there in the place of x, then it's non-real. If I put 1 in there, that's fine, it's just equal to 2. If I put 2 in there, it's equal to 1. I can put 3 in there, 4, 5, whatever. I can put negative numbers in there, whatever I want, just not 0. This question just says, determine the NPVs, which stands for non-permissible values. What can x not equal? So the first one, we already did that, 2 over x. X cannot equal 0. But if we have a rational expression like this, 2 over x plus 1, what can x not equal? Negative 1, right. Because if I put a negative 1 in there, then I get 2 over negative 1 plus 1, which is 2 over 0, which doesn't exist. So the non-permissible value here is negative 1. X cannot equal negative 1. Take a minute and think about C. How are you going to find the non-permissible values for that one? So in part C, to figure out what values of A make that denominator equal to 0, you're actually just solving a quadratic equation. 2a squared plus a minus 10 equals 0. But we actually want to say 2a squared plus a minus 10 does not equal 0. We do not want the denominator to equal 0. So I'm going to factor it. And you can use decomposition or whatever method you like to use for factoring. And we get 2a plus 5 times a minus 2 cannot equal 0, which means a cannot equal 2, like you already found just by inspection, that a could not equal 2. What number do I get from the other factor?
5 over 2. Negative 5 over 2.
Right, negative 5 over 2. Finding non-permissible values is going to be something you do in every question that you do from now on in this unit. It's going to tell you to simplify something, and we're going to do just simplifying rational expressions. We'll do adding and subtracting, multiplying and dividing, solving rational equations, all that stuff. But finding non-permissible values is going to be part of it. Because when you simplify a rational expression, it only works if you consider non-permissible values. So it's basically you simplify something and say, this is what this expression is equal to simplified as long as a does not equal negative 5 over 2 or 2. If it does equal those things, then this simplification doesn't work. So you're going to do this every single time you work with a rational expression. So now let's look at actually simplifying some rational expressions. These ones are actually all things that you know how to do. Some of them are rational numbers, some of them are rational expressions. The first two are just rational numbers. How do you simplify 10 over 5? Just make it a 2, right? Just divide. 10 divided by 5, that's 2. How do you simplify 20 over 12? Divide them both by 2, or there's a bigger number that will divide into both of them actually.
4.
Yeah, divide them both by 4. So we go divide by 4, and that becomes 5 over 3. Same thing, when you simplify something like 8x squared divided by 16x, you're going to divide them both by the common factor, which is, well, what is the common factor?
8x.
8x. Yeah, 8x is the common factor. We always want to look for the largest common factor, if we can find it. If not, we just have to reduce again. But 8x is the largest common factor. So we're going to take 8x squared divided by 8x. That leaves us with
X divided by 2.
just x on the top. And in the denominator, 16x divided by 8x is 2. So this simplifies to x over 2. We didn't in the first two have to consider non-permissible values because there was no variable in the denominator. But for this one, C, we also need as part of our answer a non-permissible value. So 8x squared over 16x is equal to x over 2 as long as x does not equal 0. That's the answer. Without the x does not equal 0, it's not a complete answer. Even though in grade 9 and grade 10 you simplified some things probably like this and didn't include the non-permissible values, now we're going to. So 8x squared over 16x is equal to x over 2 when x does not equal 0. And the last one, 6 and 4 can both be divided by 2. So we'll make that 3 and 2. I'm just going to do it in pieces instead of all together. The r's can both be reduced by r. So that leaves you with
Just
3r on the top
and then nothing on the bottom.
and no r's on the bottom. And then the p's,
P3.
p cubed, yeah, you can divide them both by p cubed, so it leaves you with a p on the bottom. So this is equal to 3r over 2p with the restriction that r cannot equal 0 and p cannot equal 0. Because if either one of those is 0, that denominator will be equal to 0. This is the kind of rational expression that we're going to be simplifying now. It's definitely more complex than the ones that you did when you looked at exponents in grade 10. But here are the steps of how you're going to do it. The process is the same. You find the greatest common factor and you divide the numerator and the denominator by the greatest common factor. That's what you do when you're reducing a fraction or when you're reducing an expression like the one we just had with the p's and r's. Find the greatest common factor. But to do that with an expression like this, we need to first factor the numerator and denominator. That's going to be the first step. Anything that you can factor, factor. Then we're going to look at the non-permissible values, actually from that step, and then divide the numerator and denominator by all the common factors. It's the same process as we were doing in those ones that you learned last year. It's just, it's become more complex, so we have to do that factoring first. So we have 2y squared plus y minus 10 that we need to factor. Is that the same as the one we already did? Yeah. That factors to 2y plus 5 and y minus 2. And then we have the denominator y squared plus 3y minus 10 that needs to be factored, which is going to factor 2 y plus 5 and y minus 2. there's everything factored. The second step says to determine the non-permissible values. I'm not actually going to determine the non-permissible values now. I'm going to do that at the end. But the reason that it's there at the second step is because this is where the non-permissible values come from. They don't come from the final answer. They come from that step. So when we want to find them, we're going to go back to this step. Now I'm going to divide the numerator and denominator by all the common factors. And what's the common factor? The y minus 2 is the common factor. We're not going to pick individual terms out of factors to cancel. Like I can't cancel those 5s because they're part of a larger factor. It has to be the whole factor or nothing. So we can cancel the y minus 2 and the y minus 2 because those are factors that are exactly the same. But then we need to leave the rest, 2y plus 5 over y plus 5. You can't cancel those 5s because they're not factors. They're terms. You can only reduce by common factors, not by common terms. The other part that I need to my answer is the non-permissible values. And like I said, we're going to get those from up here. So the numbers that make this denominator equal to 0, y cannot equal, from this factor, -5. And from the second factor, 2. All of that together makes up the answer for that simplified expression. Here's the next one, 6 minus 2m over m squared minus 9. First step is going to be a factor, the numerator and the denominator, if possible. Sometimes you can't factor, and so you won't. But here, these can both be factored. How would you factor this numerator? It's not a quadratic, right? So you're not going to factor it the same way as we did the other ones. But it does have a common factor in the numerator. What's the common factor? Of 6 and -2m. 2, right? But I don't want to take out a 2. I'm actually going to take out a -2. And this is just kind of something that's you're going to see come up, especially your textbook loves to throw questions like this at you, where it's basically in the opposite order of what you expect. Usually you expect to see the m before the constant term, but this is switched and the m is negative. If we come across something like that, we're going to take out a negative factor. So I'm going to take out a -2, and that will become -3 plus m, which is basically m minus 3, right? That factor is the same as m minus 3. What about this denominator, m squared minus 9? Do you recognize that as a special type of quadratic? It's a difference of squares. So you're looking for two numbers that multiply to -9 and add to 0. So it's 3 and -3. M plus 3, m minus 3, when you have a difference of squares like that. So perfect square, subtract a perfect square. I'm going to rewrite this just to make it, I'm going to switch around the -3 and the m. It makes it easier to find the common factor. What's the common factor? M minus 3, because it's there in the numerator and the denominator. That's what I'll divide by. I'm left with my final answer of 2 over m plus 3, but I need a non-permissible value. M cannot equal -3. Yeah, and what else? 3. So positive or -3, I'll just write it like that. You need to remember that the non-permissible values come from here. The denominator, once it's factored. That's where you find the non-permissible values. If you just looked at the final answer, you'd only come up with the -3 as a non-permissible value, but you need the +3 as well. That's what makes canceling out those factors okay. Because if m is equal to 3, then these two things are not equal anymore. 3 is okay in the final answer, right? It would make it 2/6, or 1/3. It's not okay in the original, and that's why we need to include it in the non-permissible values.